Okay, as we all know, when we have 1 to the first power, that is just equal to 1. But have you ever thought about, is it possible for us to have some other x values so that x to the x power is equal to 1? I know what some of you guys are thinking, why not try 0, right? Well, if we're looking at 0 to the 0, and let's just look at this as a computation, so no calculus, no limits here, okay? Some people will say this is equal to 1, but some people will say this is undefined. I will tell you that 0 to the 0, this right here has no agreement. I think this is really the best answer for 0 to the 0's power as a computation, alright? If you want to check out the limit for 0 to the 0, you can check out my other videos, you can see a lot more different answers. But today, let's see if we can find out more answers for x to the x is equal to 1. Well, let's just go ahead and try to solve it the usual way. X to the x is equal to 1. What can we usually do? We'll have x in the x power, right? Let's try natural log both sides. Sure. Put the power to the front, we have x times ln x, and that's just equal to ln 1, which is 0. Now we see that x times ln x equals 0, means that we have x equals 0, right? The first factor equal to 0, or the second factor equal to 0. ln x equal to 0, we can just exponentiate both sides and say x is equal to 1. When x is equal to 1, that's this situation here. And when x is equal to 0, that's this right here. So it seems that we're stuck. But don't worry, alright? I will show you guys how to find more solutions, but we just have to go to the complex world. So x will be in the complex world. But if you just do this, it seems like it's not possible, right? Well, if you want to find complex solutions, it's like right here, too late. You have to get to the complex world as early as possible. Check this out. The key right here is look at the number 1 and take that to the complex world. How do we do it? Let's write 1 into its polar form in the complex world. So check this out. Let's look at this right here. This is the real axis, and this right here is the imaginary axis. 1 is right here. And to write this into the polar form, we need two things. First is the distance between the origin to here, and denoted by r, which is just 1, and then we need an angle. As we can see, the first angle is 0, but of course you can rotate it 2 pi, or do it again, or go backwards, and so on, so on, so on. So the angle is not just 2 pi, but rather 2 pi times an integer n, because you can rotate whichever many terms that you want. Alright, and now when we have a complex number a plus bi, we can write that into the rei theta complex form. So let's take a look at x to the x power equals 1 and write 1 into the polar form. R is 1, so we just have 1, and then we need the e, and then the I, and the theta is that, which is 2 pi n, like that. Now we have more things to work with. Here, let's go ahead and take the natural log on both sides. Alright, put this to the front, so we have x times ln x, and that's equal to, let's just go ahead and cancel this, and I'll just find you some complex answer later on, you'll see. I'll just write down 2f goes first, and then pi n I like this. So how do we solve this kind of equations? X times a natural log, right? Let's try to use the Lambert W function. It's on my shirt already. To make this happen, we need to squeeze out an e, right? So take a look at the x. Let's try the x as e to the ln x power. Very nice, because right here we have the ln x right here as well, and that is equal to 2 pi n I. And now, because we see that this and that are the same, we can just take the Lambert W function on both sides. So do it here, and then likewise do it here. From here, we will end up just ln x on the left hand side, and that's equal to that Lambert W function of 2 pi n I. And then finally, to get x by itself, all we have to do is just exponentiate both sides, and then we get x is equal to e to the Lambert W function of 2 pi n I, like this. Yep, we're done, just like that. And now let me just give you guys some concrete example. So Let's say if I pick n is equal to 1. If we put n equal to 0, then the inside is 0. W of 0 is 0. E to the 0 is just 1. So let's pick 1. When we have that, we are looking at x being equal to e to the w of 2 pi I, right? And it's just 1. And enter this on Wolfram alpha, you will get approximately I, like that. So if you put this as the base and then raise to the same power, you end up with 1. Take a look. Yep, just like that.